All right, let's dive right into this explainer. Have you ever tweeted a random complaint into the absolute void of the internet, completely confident that absolutely no one would ever see it? Well, imagine if you were suddenly charged with inciting a society-wide riot because of that exact post. Today, we're exploring a seriously unusual and brilliant case study. A defendant actually utilizing advanced physics and network theory to fight a legal charge of causing severe public order disruption, all based on one single social media retweet. We're heading straight into the crosshairs of legal frameworks and the literal laws of physics. So here's the wild core conflict we're analyzing today. Can a single retweet from an account with virtually zero followers actually trigger society-wide chaos? You see, traditional legal logic usually operates on a purely linear basis. It assumes that a specific action, like a retweet, can directly cause a massive disruption. But today, we're going to examine that assumption through the lens of physics. We're going to look at the actual structural architecture of digital networks to see if that legal assumption holds any scientific weight whatsoever.
We are looking at a literal clash of paradigms here. On one side, we have linear judicial logic declaring that a single post directly caused a severe disruption. On the other side, we have the non-linear reality of modern network science. And science argues that a microfluctuation, like one isolated tiny retweet, absolutely cannot dictate a macro-level phase transition, or in plain English, a sudden breakdown of society's overall order. It's a fundamental mismatch in how we understand cause and effect in complex environments. Pillar 1, the inherently messy web. To figure out if a single user can actually break a system's order, we first have to understand the natural, baseline state of that system.
Have you ever had your feed suddenly refuse to refresh or a comment takes forever to load? Well, there's a mathematical reason for that, and it's governed by the CAP theorem. Developed by computer scientists, this principle proves that in any distributed network, like social media, designers can only ever guarantee 2 of 3 traits at the same time: consistency, availability, and partition tolerance. Because network partitions, those little glitches and disconnections, are totally inevitable in the real world, systems are literally forced to sacrifice total consistency just to remain available to users.
So what does this actually mean for us? It means that local disorder is just a permanent structural feature of social media. Chaos is a physical baseline. It's not a criminal anomaly. The messiness, the conflicting information, the localized noise, none of this is necessarily caused by a single malicious user. It's actually the baked-in physical reality of distributed technology itself.
Moving on to Pillar 2, the powerless edge node. Now that we know the system as a whole is inherently chaotic, let's look at the actual structure of the network itself and where a single everyday user fits into that massive web.
This brings us to a concept called scale-free networks. Derived from the Barabasi-Albert model, this explains how networks like Twitter, Weibo, or Facebook actually grow. And spoiler alert, they do not distribute connections evenly. Instead, they follow a power law distribution. This simply means a tiny handful of nodes have massive amounts of connections, while the vast, overwhelming majority of nodes have almost none at all.
When we break down this topology, our defendant, an account with fewer than 100 followers and 0 interaction, sits way out there in the massive outer ring known as the edge nodes. Edge nodes represent almost all users, but here's the kicker. Mathematically speaking, they possess virtually 0 structural influence over the network.
The inequality here is honestly mind-blowing. On one extreme, you have major hub nodes, think pop stars, politicians, or massive media conglomerates. On the other extreme, you have edge nodes. Being an edge node is the internet equivalent of shouting into a pillow. A random edge node simply doesn't have the structural capacity to push information out to the wider network. It's not an opinion, it's just network topology. Information literally requires hubs to spread.
Now think about this number for a second, 100%. According to physicists Reuven Cohen's critical threshold formula, networks are unbelievably robust against random disruptions. Because edge nodes are so structurally powerless, his formula proves you would have to remove nearly 100% of all edge nodes to actually cause a scale-free network to collapse. This mathematically proves their individual harmlessness. I mean, if deleting them completely doesn't destabilize the network, a single post from just one of them absolutely will not.
Which brings us to Pillar 3, the physics of an avalanche. Let's transition from the static structure of the network to the dynamic physics of how information actually spreads across it. How does a single post become a viral avalanche?
To really understand this, we use something called a branching process. Step 1 is the initial retweet. Step 2 introduces the branching parameter, which we call M. Simply put, M is the average number of new retweets generated by that first one.
For an everyday user with 0 followers, m is vastly, vastly less than 1. Step 3 shows the absolute mathematical certainty of this equation. When that branching parameter is less than 1, the information dies out immediately. It mathematically cannot cascade into an avalanche.
Okay, get ready for a massive concept. Enter a cornerstone of statistical physics, the fluctuation dissipation theorem. This essentially states that a system's huge, macroscopic reaction isn't determined by the size of the tiny external force that hits it. Instead, it's determined by the system's own internal sensitivity and pre-existing structure.
Think of it like this. Throwing a tiny pebble into the ocean doesn't create a tsunami, right? If a tiny retweet appears to cause massive society-wide chaos, physics tells us that the retweet wasn't the true cause. It just means the entire system was already highly unstable, full of internal tension, and operating with a massive response function. The ocean was already fully capable of making massive waves before the pebble even hit the water. And that leads perfectly into our final physics concept, self-organized criticality. This is often explained through physicist per-box sand pile model. Imagine a pile of sand being built grain by grain. Eventually, it reaches a critical state where dropping just one more grain causes a huge avalanche. But scientifically speaking, that final grain of sand isn't the true cause of the avalanche. The critical, incredibly unstable state of the overall pile is. The system itself evolved to the brink. The verdict: science versus the law. Let's bring all these scientific pillars together to truly understand the final clash of paradigms in this fascinating defense case.
Here is where these two totally different worlds collide head-on. Judicial logic assumes a simple linear path. You threw a grain of sand, an avalanche happened, therefore you caused the avalanche. But scientific reality proves that in complex systems, macro events emerge from system-wide criticality. A micro fluctuation from a completely powerless edge node cannot directly engineer a macro-level breakdown.
Ultimately, the physics of complex systems perfectly explains why a network might be chaotic or poised for an avalanche. But to legally blame an individual, you need hard, measurable data. You need a verifiable chain showing their specific edge node somehow bypassed mathematical probability and directly triggered the cascade. Without that hard data, blaming a 0-follower count for systemic chaos literally defies the laws of physics. Which leaves us with this final provocative thought. If a complex system naturally, or perhaps unnaturally, evolves to sit on the absolute brink of a critical avalanche, can we really, truly prosecute the final microscopic grain of sand? It fundamentally challenges how we assign blame in a hyper-connected world, revealing a profound gap between the language of the law and the actual science of reality.